Hello everybody, welcome to this week's Exoplanet Hangout. My name is Tony Darnell and I'm from deepastronomy.com, soon to be deepastronomy.space because, well, I can. And today we're going to be talking about communicating with ExoLife, we're calling it. And this was a continuation of our hangout from last week when Svetlana and Jeff, my guests, wanted to bring up and talk more about it, but we ran out of time. So that's going to be the topic of this week's hangout. These hangouts, by the way, I wanted to mention, are a collaboration between members of the Planets Foundation and Deep Astronomy. We are doing these each week, same time, same channel, and well, hopefully the same channel. Right now I'm live streaming on 3 different channels. I might switch it up, but one of them is always going to be YouTube. And it is something I feel, as the more I get involved with this, the more excited I become, the more adamant I become that I really want to raise awareness for what the Planets Foundation is doing. And so that's what these hangouts are designed to do. We have a lot of really interesting topics planned in the future, and this reminds me, I want to announce that if you want to see what those new topics are, please go to deepastronomy.com/hangouts. I just today put up a calendar that will be filled out with all of the different topics, and Kevin and I have already talked about the exoplanet topics all the way up to the first week of June, and so you can check out what those are as I get them added. So that'll be a way you can see what's coming up in the future. Okay, so as I mentioned, these are something we're doing every Wednesday, and we want you guys to interact with us when we're doing this live. And the best way to do that right now is on the YouTube Deep Astronomy channel on the watch page, and do it on the live chat window, which I have open right now. And I'm seeing Galaxia. I cannot believe you made it, Galaxia. I really cannot, because she is it's very early in the morning where she is. Swiss Milk is from the UK. Wow, you guys are awesome. So I kept thinking 7 o'clock I was going to kill you guys. You weren't going to be there. You weren't going to be able to do it, but that's not true. So awesome. This is 7 o'clock Eastern, and what time? And it's like 6 o'clock out in Hawaii, where my guests are. So let me, without any more delays, get these guys introduced. With me, joining me as he is Dr. Jeff Kuhn from the Planets Foundation. Also with me is Dr. Svetlana Berdyugina. They're both here. They're members of the foundation, and they join us each week as part of these hangouts. So welcome, guys.
Thank you.
Hi, Tony.
All right, so we're going to be talking about communicating with extraterrestrials, I guess is the only way to say it without, life from other worlds. And to be honest, I don't know where this conversation is going to take us, because I don't know how we're going to do it. I once heard Neil Tyson say something like, and I'm paraphrasing because he said it a lot better than me, but we can't even talk to our pets, even life here on this planet, another species. And Jeff alluded to that last week when he said we can't speak parakeet. So, and that's true, we really can't. So I don't know how we're gonna where we're gonna go, but these guys have talked about these things before, and so I'm looking forward to what they have to say. But as we got started, I want to remind you guys that the Planets Foundation is actually a thing. It's a organization, and Jeff, you described it in one of your first hangouts that we did together as a rogue astronomers. And you made the point, and I thought it was a very good point, that some of the biggest telescopes that have been built in our past, most important telescopes, have been privately funded. And these are telescopes like the Palomar Observatory and the Lowell Observatory and Yerkes Observatory. So can you maybe just go back to that point a little bit, talk a little more about about that idea, as well as, and kind of dovetail it into what the Planets Foundation is doing?
Yeah, so I'm not sure how to define rogue. In times past,
I should have asked you.
Yeah, in times past, I think most astronomers were rogue in the sense that they weren't funded by their federal governments to do research and teaching in astronomy. We actually are funded to do that, but a big part of what we're taking on is the old style approach to raising funds and support for big telescopes. I think we mentioned last time, Tony, that every one of the world's largest telescopes in the last 100 years or more was actually supported by private sources, not by by governments. And there's a reason for that. The reason is that federal programs have to support many, many, many diverse needs. So, for example, the big astronomy telescope projects, the 30-meter telescope or the European Extremely Large Telescope, are supporting literally thousands of astronomers over a range of different problems. And they have to be safe, and they have to work, and they have to have a broad range of optical and astronomical capabilities. And what we're advocating is really this old style of getting foundations together and smaller groups of dedicated and focused astronomers on specific problems. And the exoplanet, the ExoLife measurement and detection problem is really one of them. That's I think become the focus of a group that started a couple years ago through private money called the Colossus Group, and that has become the calling card now for the Planets Foundation, which believes that building something which is entirely new and different and focused on finding life or studying or doing a census of life in the nearest exoplanets is going to be something that happens because of private funding.
And you made the point last week that when we were talking about JWST, that we kind of have to get away from this, or astronomers need to get away from this sort of one-size-fits-all telescope mission. We need, as you put it, more focused, a problem-designed systems that are designed to attack one specific problem. Is that what you said?
Yeah, that's what the Colossus Foundation.
And you froze. Are you there? Hello? Oop, looks like we lost him. Okay, but
well,
yeah.
Maybe I continue.
Okay, yeah. Let me get you up here, Svetlana. Go ahead.
Yeah, so this is exactly the point, that once you make the telescope system dedicated to solving one particular problem, such as finding exolife, or whether it is primitive or intelligent, it's all focused on exolife and studying exoplanetary environment, then first of all, you optimize that telescope for the better sensitivity. And second, actually it makes it cheaper. And that's what two advantages, that you achieve your goal and it's for less money. And of course, this is both attractive.
Yeah, and so I want to talk a little about the specifics of what you guys are building right now. Right now, you guys are, I think you're headquartered in Hawaii, right, Svetlana? But you are a worldwide collaboration, right?
Yes.
Okay, so
I'm in Germany. Yeah.
That's right. You're based in Germany, but I think the foundation, whatever it is, but the telescope itself, the ground, the ground where it'll sit will be in Hawaii. And so, can you tell us? And the reason I'm bringing this up, folks, is that right now they are in the midst of a Kickstarter campaign where you can get involved. And the link to that Kickstarter campaign is in the description box of this video. So if you click on it, it's ExoPlanetCube, is that right? .com?
Exoplanetcube.com.
Right,
yes.
and you can learn how you can get one of these really cool exocubes, which I'm going to have Kevin describe to you in just a minute. But I'm reminding you about this. We've talked about this in past Hangouts, but I'm reminding you because it's going on now. It's important that you guys know about it. And so specifically, Svetlana, where is the Planets Foundation in your efforts? You're building right now a mirror that's going to be part of something larger.
So right now, planning for, we have several projects. So the first project is a Planets telescope itself. This is a 2-meter class to test several technologies and techniques, and also use it for studying exoplanets and planetary bodies in the solar system. So that telescope is under construction. We secured the place for it in Haleakala with some challenges which we're overcoming. And we also have primary mirror, kind of in the process, final polishing. We have engineering of the telescope and the building. So once we complete the permit papers, we will start building actually on the site.
So this is what you're building now. And Kevin, what did you have up before this? What was that a picture of?
That was a rendering of the Planets telescope.
That was the telescope rendering as it will look as when we complete it, with the, of course, housing outside. So this is without housing.
This is where we're headed. This is the first of a great many phases, isn't it, Svetlana? This is This will be the Planets Telescope. This is going to be one objective that will become part of something called ELF, right?
Yes,
and ELF
this
stands
is the first step, and one of the elements, and ELF stands for ExoLife Finder.
And that is a telescope of which there will be one of the elements that here comes there. There it is. There's ELF. Look at that.
Yes, this is ELF. Yes. So the Planets Telescope is off-axis telescope. What we say is that it's unobstructed aperture of off-axis parabola mirror. And then the ELF consists of several of such, and it has several off-axis telescopes together on one frame. So this is interferometric telescope, and that concept proposed by Jeff, and maybe he can continue with that.
Well, I just want to point out, folks, I don't want to go too far into the details other than to say we talked about this a lot in our first Hangout. Go back 2 weeks ago where Jeff and Svetlana were giving us an intro into this. But what we didn't talk about in that Hangout, and what I want to talk about a little bit now, is what comes after ELF. There's another telescope even beyond that, isn't there? Hello?
Yes.
Oh.
Jeff, can you talk?
Sure.
Jeff's back.
Sorry,
okay.
I think I dropped out here.
Yeah.
So the objective of ELF. So let me just say. So Planets is a small prototype, one step along the way. It's the world's smallest astronomical aspect ratio. So that means its thickness to its size is very very small. It's the first step in actually building mirrors that are just a few millimeters thick, and would each one of them be an element of the Colossus. So the Colossus is designed and sized in order to be able to do a census of life on the nearest 100 or 200 exoplanets near to the Earth. That means we could actually go out and we could begin to ask, is life fragile and rare, and are we particularly special in that we have an advanced civilization? This telescope has the reach and the sensitivity to be able to see the thermodynamic or the heat signature of civilizations that are not too much more advanced than we are, or the atmospheric signals of ozone or methane or oxygen that we think are evidence of biological life.
Okay, Kevin, can you... I'm sorry.
Go ahead.
No, I just wanted to point out to Kevin, but you're showing... Would you put up Colossus? Or is this Colossus that you have up now?
Yes,
oh,
this is Colossus. Yeah.
Let me put that up then. Okay, here's what we're talking about, folks. This is the final rendering of where we're headed with all of this. Each one of these segments is like the one that's being built now, but as Jeff said, it's no.
They're actually bigger, Tony. Each one of those segments
is
as big as.
But what's being built now is a prototype, sort of a test,
yeah,
concept test, right? So ultimately, these will be put up here, and we talked about why these mirrors are the shape that they are, and why they're off-axis, and the disadvantages of objectives like, or primary mirrors, I should say, like the James Webb Space Telescope and Keck, because there's a lot of diffraction and stuff that get in the way, and we talked about that in that Hangout. But this one's going to not suffer from those effects. And this is where we're headed. How big, how large is this array that we're looking at right now, guys?
Kevin's got a picture that shows a truck in the background.
Oh, okay. You want to see the truck one?
Yeah, so each mirror is 8 meters in diameter, what we plan, and it's like 59 of them in this configuration. So that will be like equivalent to 70-meter class telescope, basically. So this is something twice as large whatever plan now.
Okay, so here it is for scale. There's the truck, and to let you know just how large this thing is going to be built, which I think the plan, right, guys, is Haleakala?
No. Well, this would be in the southern hemisphere, probably.
Okay.
The site that we've talked to folks about is up in Chile.
I guess Hawaii is getting a little bit controversial as far as the spot, anyway. But the
yeah,
Andes,
it's too big for Hawaii.
Yeah. Okay, so yeah, so this is where we're heading, folks, and this is what the Planets Foundation is working on right now. So if you go to planets.life, the link is in the description box. You can learn about the project as a whole. If you go to the exoplanetcube.com website, you can learn about the Kickstarter campaign and also get one of those really cool exocubes. Now we're about to start, I promise, talking about communicating, but I want Kevin to talk just a little bit about this exocube because it's really quite cool. I have one. Mine's Proxima B. Go ahead, Kevin.
Yeah, so this right here, this is the TRAPPIST 1F version of the exocube, and I don't know if you can see, but inside are laser engraved 25 nearby potentially habitable exoplanets within 50 light years of Earth. So you've got Earth in the middle and 25 exoplanets kind of scattered around, and then the majority of these exoplanets are also in their own constellations. So what we did is we separated the sky by constellation and tried to really find exoplanets in those constellations that we feel are most likely to harbor life. And it comes with a really cool mineral sphere that sits on top that you can kind of spin around on your desk.
Awesome. Okay, thanks, Kevin. I appreciate that. So, all right, so let's get started. We are going to... we'll be going back to this periodically as time goes on. This is obviously a long-term thing for everyone, but for us, we're just getting started, and we want you guys to get involved as quickly as possible, or in any way you want. I mean, Larry Keys was already talking in the chat about wanting to get involved with some of the image processing and in some of the science that's being done. And there will be, we talked about this in past Hangouts, a citizen science component at some point set up by these guys. And as soon as that happens, you'll be the first to know, and you can get involved. Jeff even mentioned a nice way to go about perhaps doing that. So look for that in future Hangouts as well. Okay, communicating. Svetlana, I'm going to let you go first because you brought this up last time, and Kevin is sharing something, so I'm going to put it up. That's up now.
Yeah. Okay.
Go ahead.
Yeah, so I think it's a very exciting subject. I mean, certainly we first search for life, and we search in different ways. We search life which communicates either with us or communicates with some other life, or we try to communicate with it. So it's all about communication. And communication is what? Our definition of that is sharing the information. So we send and receive information. So that was the subject of my public talk once last year, and there is YouTube link to that also on our planets.life page, and this is what I kind of brought together in one talk, and I can highlight some interesting facts from that. And so the first question, of course, is that how we recognize that somebody tries to communicate with us, or how we can communicate with something else, what is not us. And as Jeff mentioned it last time, and you pointed out today, and I also discussed in my talk, that one thing is to test is trying to communicate with animals or try to understand what animals say. So these different aspects, communicating with some other life forms, not humans. Even with humans, sometimes it's difficult. So
I know I can't even communicate well with each of my own
right.
son. So.
And what I find fascinating is that what some psychologists say that life cannot not communicate in a sense that humans communicate all the time, even if they don't speak. And that if we just kind of extrapolate it to all other forms of life, we do expect that all life forms should communicate. And that's why we're so persistent in searching it. And of course, the SETI program, Searching for Extraterrestrial Intelligence, is the main, it's like already a long-lasting program, lots of effort to find communicating life. That is unfortunately not yet having results, but we're still optimistic.
Okay, so you say that life can't not communicate, that it does it by default, but I mean, it certainly doesn't do it very effectively, does it? I mean, let's, for example, we're communicating, I suppose, with the bear when we shoot it, I suppose, yes. Or when we trap it. I suppose that's a form of communication, but are we really making any meaningful dialogue there? And what do you mean by communication? Is it just, to me, it's like message needs to be sent and a message needs to be received and understood for any kind of, communication to be effective. So what do you mean by communicating?
Yeah, so there should be a content of the message and a form of transmitting that content. And what is interesting is that interpretation of that message is also would be quite difficult. So when you communicate a certain meaning, you imply that you have to be understood, but it's not necessarily granted. So it's also like when we search for the signals, when we try to listen to radio communications, for instance, or of other civilizations, even if we hear the signal, even if we decide that this is a signal of communication, to understand that signal would be incredibly challenging and maybe even impossible. So that's a big obstacle.
Also, you're saying that we may not be able to actually do this then.
Yeah. So that is, or let's say we most probably will try to interpret it somehow, of course, but it's not necessarily that our interpretation will be correct.
Okay. Jeff, let me get your thoughts on this. So my feeling is that communicating effectively has to be all of the things I just outlined. Do you think that's ever, and I'm going back to animals because, well, that's a good example, something we can all understand. When I'm looking at squirrels in my backyard, they're yelling and chirping at me. They want me to go away. I mean, I get that message. So that, I suppose in that sense, it was an effective communication. But,
yes.
What do you think about all of this?
Yeah, what studies showed, of course, there are studies to learn about animal communication and language, show that you can understand it if you have a context of that message. So imagine if you don't see squirrels and you just hear them chirping, how would you interpret it? So that means the context of the message is very important for interpretation. And that was proven that changing by context, you can decipher messages. So in sense of alien communications, it will be difficult to see the context of that communication. So I think the goal would be like, okay, to receive the message and then try to find out what is the context of it so that we can understand it.
So you're saying context is going to be a big challenge.
Yes.
Okay, so Jeff, do you have anything to add to this?
Well, so communication could mean just affecting the behavior of something, and that's what you're doing when you yell at your squirrels and when they try to chirp at you, and that's a simple form of communication. And I think there's a chance that we can show that we affect the behavior of the primitive or more primitive life around us. Right? I think we're learning about how dolphins communicate. They show, some scientists would say, they even have language. Dolphins have been recorded chittering and beeping and
whales
and
too,
whistling,
yeah.
and whales
singing songs, yes.
And the interesting feature of what they do is that one will go on for a while and the other one will listen and then respond, and it's not often like how birds seem to communicate, which is simultaneously. So there's evidence of language, which is this higher form of communication, but communication in its simplest form, which is just affecting other living beings by things that we do, I think we have a chance of being able to do. I think that a lot of what we're thinking of with SETI, which is that evolution will naturally take advanced life into a phase where universal languages like mathematics can be developed. It might actually be that very advanced life, maybe life more advanced than we are, we have a better chance of communicating with language than we do with simpler life. And I think we know that the problem of communicating with simpler life is probably impossible, because here we are sitting on the Earth and we have not really communicated with any single species except in the simplest form of doing things that show that we affect their life and they affect our life. Okay. So I'm hopeful that the answer is going to be more advanced civilization, more advanced life evolves into a similar kind of mathematical language that we can work with.
Okay,
and of course,
exactly.
Yeah.
That seems to be the main hope, especially when we're talking about across the stars. I mean, it's one thing to hope to talk with life that's here on the planet. The way we would go about that would be a lot different than if we're trying to span light years of distance to try and do the same thing. Uric Mazino is commenting, and I'd like to get your thoughts on this. What is the basis of communication? Did it first start as chemical communication between organisms that must mate? And if an alien life reproduces asexually, would they have evolved communication? That's a good question, Uric.
Yeah, in life, it is molecular communication, yes. At the very basic, at the basis of single cells or single cell organisms, it's molecular communication. And then the communication within the organism became this electrical signal when the synapses was invented. So now in our bodies, in human bodies or more advanced life bodies, we have both electrical signals and molecular signals.
Okay, and Galaxia is commenting, communication with aliens requires photos and images. That's an interesting point. I mean, and
music.
And music, right. So, I mean, yeah, visual stuff is pretty important to human beings, but maybe not necessarily to an alien life form.
Right.
I guess what I want to know is, guys, where do we start? I mean, SETI is already out there. We know about SETI. SETI is listening to all these frequencies all at one time, and they're looking for anomalies, and they haven't found any yet. Can we do any better than that right now? Is that all we've got?
So maybe, yeah, Kevin, if you can show slide number 5, that's the example of communications with aliens, kind of. Okay, so what Jeff said, yes, it would be probably easier to communicate with intelligent life, because we have proven on Earth that communicating with life, which is not very advanced, is very difficult because it's completely different set of language. And when I talk about context, then communicating with the intelligent life, what we think is context, is science, is mathematics. And so kind of in that direction, there are studies that to develop some mathematics and physics-based language, which we can transmit to intelligent civilization and think that may understand it. So this is the example of broadcasting, and was done in 1999 and 2003 towards several exoplanets. So this is called ideograms. So the scientists developed this kind of hieroglyphs, which are ideograms, ideoglyphs, they call them, ideoglyphs, yeah? So these pictograms, they are numbers, they are mathematical constants like pi and so on, and physical constants and so on. So there are lots of sections in that message. It's a very long message based on these pictograms. And the last section, which is shown here, so section 12, it's questions. These are questions we ask from extraterrestrials if they can answer. Okay, so I find it very...
Hang on, Svetlana, I got to back you up here. We're looking at an image of, you've got the dish on the left, and then you've got 2 inset arrays, yes, or tables. One says numbers, which are 4 by 7. The other says section 12. And then there's these little dots. These are called, what did you call them again?
Ideoglyphs.
Ideoglyphs. Okay.
Yes.
And what do the dots represent? They're different.
So this is like a binary code, kind of, black is 1 and empty is 0. And that code represents different ideas. So this is like in hieroglyphs, you have concepts. So each symbol is a concept.
So the number 0 then, and the numbers that's 4 by 7 is the picture of that is off to the left of the number 0, right?
Yes.
So
yes, exactly.
That is a ideoglyph of a number of the numeral 0.
Yes, exactly.
And then the numeral 3 and 6 and 9.
Yes, exactly. So that is like, you have first you transmit, the suggestion is that first in such messages, you have to submit some kind of simple, this is already too complicated, but something simple modulation, like a Doppler modulated signal, which will attract the attention to the message. So first you say, hello, whatever, like,
it's like shining a flashlight pass back and forth or something, get some
Yes,
attention.
exactly.
Okay.
And then you start to send some meaningful signals like this 0, 1, 2, 3, and then based on that you go further and so on. And then in the end, it becomes hopefully learned by other advanced civilizations, which is challenge for me here actually personally to understand what are these questions about. So in the end of the section 12 is shown here. These are the questions we sent already to ETs. And imagine if we get the answers in like 90 years from now. So I'm afraid we will be in the same situation as in that book, that the answer is 42, and we don't know what's the question, you know? So that is
Douglas Adams, yes.
kind of funny, yeah.
Okay, so I know for a fact that if I saw this, I wouldn't understand it. What is it about these idea glyphs that makes, I would think that whatever message we sent, and you talked about the context in the past, we'd have to be pretty kindergarten about the whole thing, right? I mean, we kind of were with the Voyager record that we sent back in the 70s.
Yeah.
But this doesn't look simple to me. I don't understand the message. How?
Well, that is a language which we have to learn ourselves. You know, that was artificial language created, and that's what scientists do. They create artificial languages based on mathematics, and like universal language, which might be understood by intelligent civilizations, and that's the idea how we can communicate to create the context based on mathematics and on physics and the universe we can see.
Well, I'll tell you what stands out to me when I look at this is that I know it's probably not. There's certainly patterns there, and that tells me, oh, good, there's something non-natural. I hope non-noise-ifying there. But this is an interesting. So this is something. This is something that's already developed. These ideas. Who developed these? Did you develop these or?
So let me think. This was Canadian, I think. This was Canadian scientists who created that message. Yes, okay. And then they found private. Again, we talk about this private support. So they found a private enterprise who paid for broadcasting of this message.
Okay.
So
we have
and I mean, we can look at a receiver message. This is slide number 3, Kevin. And then you see, a receiver message was so cute and small and understandable, even though there are also still some challenges to understand it.
Oh, hang on. Let me put it up here.
Here
Hold
it
on.
is.
There we go. Okay. So you've got an Arecibo message. Oh, I remember this.
Yes, that's a receiver message. It's also out there towards the globular cluster, which is 25,000 light years away. So that's far away. Yeah, so this kind of messages, and you see the context of this message is again mathematics and physics. So we say, and chemistry here. So we say numbers, 1 to 10. We show like most important chemical elements, atomic numbers, hydrogen, carbon, nitrogen, oxygen, and phosphorus. Then we show sugars and bases, which are in DNA. Then this double helical structure of DNA, the human, solar system. So I don't know if I remove all these explanations in English, would you be able to understand what's there?
That's an excellent point. When I look at it, I go, oh yeah, okay, sure. There's now the numbers, I guess, looks like numbers 1 through 10, and sure, that's a DNA, and obviously there's a person. That's cool. Yes. I can see the person. I don't get the size and population out of that, but I do get to see, that there is a person there. So
that's numbers, yeah. Population is in numbers. You see that numbers are on the top, and then you kind of get the numbers.
So from that legend along the top, you're supposed to be able to. I wonder what all filled in means. That must be infinity, I guess. But
yes.
Okay.
So this is a challenge. I mean, we're super biased in creating these messages. We're using binary code. Assuming that's something universal. We construct numbers, assuming this is something universal, and so on. Jeff, what do you think about it? Would you be able to read this message?
No.
Yeah.
Yeah, that's hard.
Yeah. I have to say, if I looked at that, I'd be like, if I just got this as a stream of radio signals, I'm not quite, it would, but there's a lot of smart people in the world. Who knows? But I don't know how. Go ahead, Jeff.
Think back to the movie Contact.
Oh yeah,
Do
that's what I keep thinking of here.
Yes.
Yeah, remember the story of how this very advanced civilization was able to actually encode into nature itself. In Carl Sagan's initial book, and his book that became the movie, it was a little bit obscured in the movie, but it was nature itself, in this case pi, the ratio of the circumference to the diameter of a circle, that were encoded information about how to contact and how to decode the information that eventually would lead to some sort of contact with this civilization. So it could be that nature itself encodes the signal from the most advanced of civilizations or life ahead of us, and this is just a feeble attempt to make scratches in the sand. But my feeling is that where communication could be a very simple thing, which is just to affect other life. And in the case of a civilization which is not far away from us, the simple act of detection and anything that we would send back to that civilization would be communication, because we would affect life here in a really profound way. And you might use that as a definition of the simplest form of communication.
Just being there, just seeing each other.
Well, sure. Just the fact that life is not so fragile that we're the only outpost of something we can identify with life in the universe. The identification of anything like that anywhere else is going to be the most remarkable event, I think, in human history. And we can hope that it's a conjugate relationship, that once we detect life, we might choose not to if we're paranoid. But my feeling is that physical transport over such large distances doesn't really work like Star Trek, and that we'll be transporting information as evidence of life, and even ultimately the things that make what we call real contact work. So I think that communication could be something that happens pretty naturally and almost unavoidably, and this language that we want to send or we want to communicate with eventually could be something which is just encoded in the laws of nature.
Right. In one of our future hangouts, I want to talk about just what life is and what it even means to be called life, and we're going to talk about that, I think, in future ones. But one of the things you alluded to this, I think, last week, Jeff, and we've talked about this before, about this idea that DNA-based life isn't necessarily something that anybody else would recognize, because it could actually be built on other things besides DNA. However, another really important, this occurred to me as we were talking, that another form of communication could simply be the act of taking data, a spectra from an atmosphere of a planet that has a lot of bacterial life in it, perhaps, and those signatures, those gas signatures of life would be present. That's a form of communication too, isn't it? For example, increased concentrations of methane or something like that.
Yeah, this is a natural communication. This is like, yes, there is a lot of information encoded in nature, and nature communicates to us, but like what you call life and communication, which is transmitted by life, that's somewhat different, I would say, isn't it?
That's a long conversation, Tony, and I think all the professionals, even at the big astrobiology meetings, still debate what is life.
Oh, we're going to talk about it. We're not. You're not off the hook. We're just not going to do it today. Okay.
What is life? Yes, it's an endless question.
What do we mean by that, and what are the factors involved in actually being alive? Yurik Mazno is also commenting, is there a worry, or questioning actually, is there a worry of sending a message to a species that can receive but is immature in development? The consequence would be significant, would it not? I mean, it's one of those things where they might get our message, but they don't have any way to transmit it back. That's a possibility, right?
Yeah, well, that is a bottle message may arrive or may not. Like we send Voyager.
I like that.
Yeah. We say in Voyager somewhere, we don't know where it ends. So it's now, by the way, like 120 astronomical units away, one of them, 125, really far.
Yeah, and he's also, boy, you're on a roll here. Let's go. If there is life out there that's advanced and developing, would they probably be asking similar questions that we are? The confusion wouldn't matter as much as the fact of existence. So I think that's what you were saying. There's sort of this natural communication, this ability to just announcing that you're there is
that's a possibility.
A huge step forward. Doesn't matter so much what we're saying as the fact that we're saying it.
Yeah, exactly. I mean, when we teach children to speak, we say mama and say 1, 2, 3 and count. This is simple things we teach, and we try to teach this to the animals, and they really learn fast. And apparently, if life is intelligent, it can learn pretty fast, especially if the message persists.
Kurt Semir is commenting, remember, just 60 years ago, bouncing an HF signal off the moon was seen as impossible. Yet I can do that today with my high-frequency radio if I really wanted to. That's right. Silva Damata is commenting or asking, given the likelihood that ExoLife will be different from us, how likely is it that alien intelligent life would have to be supported by structures similar to our brains? Any comment on that?
Well, our brains are based on electrical signals, let's say, and we know out of 4 interactions, fundamental interaction, electromagnetic interaction is the strongest. So it's possible. And also like how to communicate, in which way. We communicate with electromagnetic signals also to the universe, and we receive a lot of electromagnetic signals as well. That's what light is, and radio signals. And apparently that will be the dominant signal. Of course, you can send particles and communicate with particles. But I think that electromagnetic signals would be something preferable. Also, like inside us, in our brains and in our muscles, it's all electrical.
Yeah, and I just wanted to comment on Kurt Semir's previous comment about just what we didn't know 60 years ago. 25 years ago, we did not know there were other planets around other stars. So things are happening quite quickly, which brings me to Michael Sustrick is commenting, how about music? Blast Metallica out to the cosmos. No, man. I mean, okay, Metallica's great. You got to do Pink Floyd. It's got to be Pink Floyd.
Music was sad, yes. The question is that what do you understand if you listen to extraterrestrial music? What do you understand it?
Everybody understands Pink Floyd. Okay, I'm sorry. Deicide is asking, I hope I'm pronouncing it right. Deicide, is the Drake equation still relevant, or have the parameters changed? Now, that's a great question, and I want to talk about the Drake equation. We do know that one of those parameters, Fp, which was the fraction of stars that have planets around them, we have a really good idea now of what that is, about 1.6 for every star in our galaxy. Do you guys want to comment on the Drake equation a little bit?
Well, the Drake equation was always not really an equation. It was just
a bunch of things thrown together.
Well, no, it was a place to focus the uncertainties that you maybe hadn't really chopped up into little pieces that are easier to understand. And as you point out, one of those uncertainties is a fraction of stars that have planets. But there's so much prior history built into that equation. So, for example, it may very well be that life is not on planets or on other stars, but on free-floating objects in the galaxy, in the universe. It may not have anything to do with the location of stars if you look at life which is sufficiently advanced. That equation is written as if it's a set of independent terms, but one of your earlier commentators asked about how likely is it that some other life would understand anything that we do. And I think that, for example, if you take the view, which is entirely irrefutable, that life is a cosmic phenomenon which is transported via comets. I think we made this comment last week, that panspermia is by no means a wacky idea. And it's especially interesting when you think about the timescales that biology now thinks we need to have to be able to evolve all of the complexity of just even the earliest ingredients of life. So suppose that life is this diffusive phenomenon which is being distributed from one place to the next in the galaxy by big snowballs or big asteroids in the centers of them. Then this corner of the universe could have a lot of life which was seeded at about the same time and which has the same basic ingredients, maybe even the same DNA structure. The local forces of evolution in the environment would, of course, change the life in very different ways from its changed life here on Earth. But ultimately, it could be that for planets that have water, like the Earth has water, that there is a common framework and that we don't have to build life from scratch in every different environment, but that it has a common thread somehow from some earlier event, much earlier in the history of the galaxy. So I think when people talk about, well, can we really calculate or understand the probability of life? What's happening now is we want to make that an experimental rather than a philosophical problem. And I think that's the point of this private enterprise that a bunch of scientists are now pushing for, is that we have technology to be able to make the questions that we've been asking for a long time about life into empirical questions by doing, for example, a census of life on the nearest 200 exoplanets around us. If we found nothing, that the mere fact that we have the sensitivity to see signatures of life tells us a lot about where we are in the universe. And maybe we'll be more careful about not blowing ourselves up if we know that life doesn't have another chance anywhere nearby.
Yeah, that's an excellent point, and it's also going to be the topic of a future hangout where we're going to talk about just how common life might be, because that is, to me, the question to be answered. I'm going to read a couple of comments. Kurt Semler is jam them with the Meow Mix song. Really, dude? That's just harsh. I mean, that's awful. And of course, with with Metallica, at least you get their attention. And Metallica, I will say, I just want to say for the record, I love Metallica. But you don't. You want to set the right mood, and that's only done with Pink Floyd. I'm just sorry. Attila Jacobi, I hope I'm pronouncing that right. Do you think, and this is a good question actually, do you think that we will be able to communicate using the quantum entanglement principle? Quantum entanglement is this idea that two particles who've interacted with each other are suddenly on the other side of the universe. They move to the other. Whatever happens to the particle left behind, the other particle will instantly know about that. That's the way I always explain entanglement. It doesn't help because the whole idea of it is crazy. But maybe you guys can comment on quantum entanglement as a communication.
Yeah, that's a very attractive idea, to communicate on large distances instantaneously, basically. Yeah. But I mean, if we fantasize a little bit, sure, why not? We can create a bunch of particles, and but then you have to wait as a large separation to separate those particles until you start to communicate with them. So, I like this idea.
Okay, well, Archie Gullen is asking a good question I want to get to. Will aliens be able to listen to our radio signals after 1 million or 1 billion years from now? I mean, does it decay, meaning the signal, the radio signal, decay while traveling through space or not? That's a good question, good science question. What happens to radio waves as they are transmitted from the Earth out into space? What can happen to the signal, guys? I say guys because I'm just going to let either one of you blurt it out.
Jeff, maybe you say.
Well, I have to comment on entanglement first.
Oh, okay.
Entanglement is an important principle of quantum mechanics. It's actually even a classical principle that if you have conservation laws, there's a relationship between particles here and particles far away. But as important as entanglement is, it also says that you can't actually transmit information, that you can't do something here which provides useful information far, far away. There is a connection, there's a relationship, and my life is somehow connected through causal channels through somebody who's 12 stages removed somewhere off, the butterfly effect, if you want. There is a determinism at some level in the universe which makes things entangled, but it doesn't mean that I can choose something and communicate that something instantaneously over distances. So I don't think
But
entanglement's going to give us a faster way of communicating.
if you have several particles, and one particle does one thing, and it's like binary code, you can create a binary code. The thing is that somebody has to look at those particles which you try to manipulate.
Sorry, I'm sitting here trying to visualize all this and not getting very far. Okay. Yeah, I get your point about this. It is an effect that you are entangled, for lack of a better word, with some other thing 12 degrees removed, but you can't necessarily control that. So that communication level. So that's an important point. Who knows that we can in the future? But
suppose we don't really have free will. Then we're completely entangled, and everything that I do or I think I do is determined or is deterministic to something on the other side of the universe.
Yeah.
So this question of entanglement and communication, first off, means I have to have free will, and then I have to be able to choose something, and I have to have the option of choosing different things, and that option or that event is not part of any idea related to entanglement. But this is philosophy as much as it is.
This is a lot of philosophy.
Well, it is right now, at least. But let's go back to Tilla's question on what happens to radio signals as they.
So radio signals, like everything, they travel outwards in a spherical beam, unless we were to make something like a laser beam to send a signal out, and then they still diverge. But as they diverge, it's just like water waves on the ocean. If I drop a pebble in a perfectly smooth ocean. I'm in Hawaii, and if this happens over on the neighbor island, on Oahu, by the time that ripple from that pebble, which you could see easily in the ocean in Waikiki, by the time it gets here, it's too small for me to be able to measure it. So radio waves, the further they travel, the longer they're out there, and the further back in time you could look, but you have to have a much more sensitive way of detecting them, and they drop in amplitude in a way that means 1 million years from now, maybe some very advanced civilization on the other side of our galaxy, that's a few 100,000 years. 100,000 years from now, a civilization on the other side of our galaxy could possibly be listening to Archie Bunker on
our hangout,
or our hangout if it's being broadcast outside of the internet. But that's. Time and sensitivity are both our enemy.
Another thing that can get in the way, it happens all the time with electromagnetic radiation from stars, is gas and dust can absorb it, so it can get reflected and get absorbed from particles in the way. Lots of things can block it, so you want a clear view of where you're going. It actually does matter if there are not a lot of stuff in between us and the people we're trying to send radio signals to, although radio does a really good job of getting through the interstellar or the interstellar medium better than, say, visible light or things like that.
Yes.
But things can get in the way of radio signals as they go out too. Let's see. Kurt Semler, yes, it does. Spooky action at a distance, i.e. quantum entanglement, would be effective subspace communications if we could master the technology. Well, that's a big... You're right. Okay. If we could master that,
Yes,
I think that's fair to say. Larry Keese is saying entanglement does not include information. Is that what?
That's right.
But I thought you said it did.
No, you can't transmit free will or information. The fact that a particle decays with a particular state on two particles leave, they satisfy a conservation law. They travel apart. You make a measurement over on this side, and somehow instantaneously that means you know what the state is of the other particle. But I can't flip this particle because I want to transmit something and have it appear instantaneously over there. The issue of the collapse of the wave function, which is really the quantum mechanical concept, which is entanglement, is not something that I can use to transmit information from one place to the next. Okay. Well, unless life and everything that is us is deterministic. And if it's deterministic, then I don't actually have a choice as to what I could do over here, and therefore what is over here is determined. I just have to figure out the laws of the universe with sufficient accuracy that I can predict all that. And so, I don't think that it's a question of technology with entanglement. It's really a question of determinism.
Okay. Sean Castor is asking a really loaded question. I'm going to go ahead and ask it. When we finally do find evidence of life beyond Earth, he's saying when. Okay, he's just not.
Oh,
that first of all, how do you think?
Soon. Stay tuned.
on Tuesday, when we finally discovered life, how do you think that will change life on Earth? For example, with religion and so on. Now, this is going to be strictly everybody's opinion, and I should. That's actually a good question for my wife's a philosopher. I should have her answer that question.
Oh,
but,
bring her on.
Yeah, I should. I think I will invite her next time.
You should.
But yeah, so I don't know. Any thoughts? I know that you don't have to comment on that if you don't want to. But how do you think that'll change us? Maybe just culturally, even.
Of course, it will change us, and that's important. And that change, Jeff mentioned earlier that we learn whether we have a chance to survive longer, and that in the Drake equation there is this term, a factor which is average lifetime of intelligent civilization. So if we just plug in the life what we have, like couple of thousands or whatever, 10,000 you plug in, it's minuscule. So we do hope that civilizations last like 50 million at least to find a few of them in the galaxy with all those factors involved. So that is a pretty long lifetime. So when we can find signals from a civilization, we can say, like, approximate, okay, that means that average time of civilizations, average, it's not necessarily hours, but average time of civilizations is several million years at least, and that's a hope for us.
Jeff, you want to comment or just let that one go?
No, it's a good question. I think, when we look around on the earth, the Christians and the Muslims and various other religions each believe they're the one true religion of mankind, humankind, even though we can look around and we can see others that have equally strongly held beliefs. So it may not be that if we find life somewhere out there that it affects our religious beliefs. But I think it does change the way we think about the fragility or the possibility for where life goes from here. And I keep thinking about when we build Colossus and we do a census and we look at the nearest 100 exoplanets and we find life on 25 of them. I think that we're going to at that point we're going to say to ourselves, "Gee, we're not special." I mean, that's a sociological statement, and I'm convinced that one of the great contributions of astronomy to humankind is the demonstration that we, by any measure that we can apply, are not special. Our planet is not special. I could not agree
with that more. That is absolutely what I get from astronomy too. It's a humbling, incredibly humbling endeavor. So well said. That was very good. There was. I'm sorry. The thing started scrolling and I lost my. Shoot. Okay. Let me just pick one. Let's see. What if? Hold on. So I'm sorry. I got lost where I was looking at the live chat. I had a really good one I wanted to find, and I'm trying to find it. Connor Farrell is asking, what if we are so unevolved that there is intelligent life nearby, but we are so dumb? Oh, wait, I know what it was. Here it is, Urix. I'm going to go back to yours in just a second, Connor, but I want to ask the Urix question because that's where I wanted to go with this. Any thoughts on a more intrusive communication method, like sending very tiny probes near the speed of light to nearby star systems? Well, that speaks to this initiative, this breakthrough, What is it called? Breakthrough Starshot?
Breakthrough Starshot,
yeah. What do you guys think about that way of communicating? That's where, thank you, Urix. And I'm sorry I had
This is an excellent way of communicating, yes, kind of polluting the environment, but I think that's what we always do.
Is that throwing stuff out there?
Yes. Well, but that's okay, maybe that's us also, a descendant of those pollution, so that's fine, I think.
Okay, go ahead. Do you want to comment, Jeff?
Yeah, so we should go back to another epochal science fiction story, 2001.
Yes.
I don't think I'm not sure everybody understands it, but Arthur Clarke was a big fan of the argument that the best way to send and communicate with the universe was to send probes into the universe that could self-replicate.
Right, those
which means that
in that story.
Yeah, that's what the obelisk was. The obelisk was a self-replicating probe that contained information and could reproduce itself by natural means from the environment that it landed on. And a lot of great scientists in the 50s and 60s were not arguing that the way to send a message into the universe was a radio beacon, but the message in a bottle. But it was a very special bottle that every time it got hit by a big wave, it could double itself, so that you could do this exponential thing where you could fill the universe with little memory sticks that provided a really good signal for those that had an environment where they could actually double. And now you ask the question, well, what sort of, maybe it's not an obelisk, it's the best message unit. And if you think about it for not too long, I think you'll realize that the best message unit is a biological machine that's self-replicating. And
this is a possibility to send a message or colonize the universe with our own species or similar.
We're the message. In a
yeah,
sense.
we are the message, but it's not a communication anyway. It's like we are the message, but who receives it? It's like it can be not received.
I am so happy you guys brought up self-replicating probes, because Kevin, remember this. This is going to be a topic of a hangout. I know of a paper where a guy figured this out, where we're going to talk about this in a future hangout on self-replicating probes and the mathematics of how fast you could cover the galaxy using this technology. It is phenomenal. You can do it in human lifetimes.
It's very fast, yes. Amazing.
Exponential growth. So we're going to talk about that in the future. Thank you for bringing that up. That's a topic for another hangout. And I want to get back to Connor Farrell, and then we got to get going. What if we are so unevolved that there is intelligent life nearby, but we are so dumb that we can't even recognize it? It's just like how ants don't think, oh, that's a human, watch out. So I guess he's not giving us much credit for being up there on the scale. But could somebody be trying to communicate with us in ways that are so over our heads? We're just...
The lizard people.
Absolutely, yeah. Well, this is called like ontological limit, if you ask philosophers, yes. This is something which is impossible to communicate. How can we communicate with single cells, with bacteria or amoeba and so on? It's impossible, and we can be such amebas to others. That's true, and here means that we have to grow. We have to still become more advanced to understand
others. What's it called again? What'd you say?
Amoeba?
No, what kind of communication was it, did you say?
Ontological limit.
That's what it was. That's what. Okay,
yes,
ontological.
Yes.
Okay, great.
So this means that it's incomprehensible for us. Yes.
Okay.
Well,
go ahead.
Or just to say that in a different way, life which is too much more advanced or too less advanced to us, we couldn't really have a conversation with. Language is also about how our brains work, and I don't think we would know or be able to have a useful conversation with a cockroach. Maybe we could. Maybe that's just at the limit. But certainly we can't have conversations with bacteria that are meaningful. And it could be that our relationship and our development in comparison to other life that's been around much longer, advanced much further, we couldn't have that conversation. So there's a window of communicability or language communication, which is I think probably as limiting as the distance or the signal weakness of distant exoplanets. That we have to be in that window.
I would say in this sense is that primitive life can consider the more advanced life as an environment, perceived it as environment. Like, for instance, bacteria in our bodies cannot perceive us as intelligent species. They perceive us as environment. And that is kind of this ontological difference and this limit that for us at this level as we are, looking at the universe and thinking, whether this whole universe is intelligent species we live inside or its environment. So to distinguish very high level of intelligence from environment, I think that's difficult.
So just one more point, which I think was initially made by Arthur Clarke, where he said, or maybe it was Kardashev, any sufficiently advanced civilization wouldn't be distinguishable from magic. But
Yeah.
really the corollary to that is any sufficiently advanced civilization might not be distinguishable from nature.
From the environment, yes, that's what I'm saying, from nature.
Wow, that's a good point. That's an excellent way to put that. Okay. Let's see. A couple more comments here. Shahid is like, hello from Manchester, UK. My first time. Riveting stuff, guys. Thank you very much. I spent a year in Newcastle. I love the north of England. I love it up there, especially the northeast.
You like cloudy weather.
Glad you guys are making it. And so I think we better stop it here. There's still stuff going on here. We will be looked upon as ants when Skynet wakes up. And Swiss Milk is commenting, AI will help us move very fast with new techs, I think. That's a good point. We haven't even talked about the effect artificial intelligence.
That's also an interesting topic.
On our ability to do that. So the thing, Kurt Semler, the thing about current tech is that it's current. Anything else is just an act of the imagination. We don't even know if subspace comms are physically possible yet, or even, I don't even know what subspace comm is. So, yes.
Star Trek.
I know, but they don't define what a subspace is.
Well,
it's like not warp space, right? That's what that gets. Yeah. Okay. All right, folks. Well, we're going to stop it here. I want to thank everybody for participating. It's another great hangout. We will be back next Wednesday where we are going to be talking about, I already forgot what the topic was. Ground-based SETI search for terrestrial efforts, and we're going to be talking about those next week, followed by all these other different topics that we're going to be bringing up. And I'm definitely going to put self-replicating probes on there. So please, guys, I want to take some time, check out planets.life, check out their website, learn about what they're doing. This is a big deal, folks. This is a way for you to get involved now. I think this is one of the most important things going on right now. So I want you guys to learn what they're doing. Check out exoplanetcube.com. If you want to get financially involved, they could certainly and get one of these really cool exocubes. So I guess so I want to thank my guests, Dr. Jeffrey Kuhn, as well as Svetlana Berdyugina from the Planets Foundation. We're coming back next week, right, guys?
Thank you. That sounds great.
All right.
And I would like to thank also those who listen to us and ask questions. That's really interesting questions that you ask. And we also learn from your questions. You force us to think, and we are kind of, okay, that's something inspiring. Thank you.
That's right. And so keep bringing them. Yurik, Ken, Swiss Milk, all of you guys, thank you guys for participating and hanging out with us. We will see you this time next week on Wednesday at 7 p.m. Eastern Time. Thank you all for watching. And as always, keep looking up. Now I have to